I'm your host, Grayson Brulte. Welcome to another episode of SAE Tomorrow Today, a show about emergent technology and trends in mobility with leaders and innovators to make it all happen. On today's episode, we're absolutely honored to be joined by ZEV Station's Jesse Schneider, chair of the SAE Wireless Charging Taskforce, and WiTricity's Kai Seeley, Subteam lead of wireless charging alignment. On today's episode, we'll discuss the newly released updates to the J2954 standard and answer the question, how close are we really to commercializing wireless EV charging? We hope you enjoy this episode. To kick things off, gentlemen, inductive wireless charging, it's becoming a hot topic. Individuals are talking about it on social. I've become fascinated with it, and I'll say this very bluntly. It's the future, and we can't wait for it to come here. In order to become the future, you have to build a standard, and that's what you gentlemen work very hard on. And Kai, to begin the conversation, how close is the industry to commercializing wireless charging?
Yeah, that's a great question. So wireless charging has been around as we know it in cell phones and has been increasing in adoption. But as far as adopting into vehicles, we're really starting with the OEMs. So OEMs are now looking at how to integrate this technology fundamentally into their vehicles so that EVs naturally have that as an option. Of course, there are add-on aftermarket options that will be available maybe in the nearer term, but ultimately adoption will occur when the OEMs have the receiver built into the vehicle and that can accept the charge readily.
Kind of from a consumer acceptance standpoint, consumers are used to putting their phone on a table, putting their phone on a charging device. Do you feel that will start to help build that customer acceptance where they're already used to it? Wait a second, I don't have to plug this in anymore. Does that start to help to build that public acceptance as technology scales?
It certainly helps, but I would note that the way that we view cell phone wireless charging technology today is still rather contact-based. You still have to place it on top. In the vehicle world, this is very much different. There's a large air gap between the ground assembly or the pad on the ground and the vehicle assembly that receives the power. And we don't require that very tight alignment that people may be used to with the magnetic connections on the cell phones or the very tight coupling that's required. So this is sort of the next leap in generation of wireless power transfer. Okay,
so this is me just being simple. It becomes almost Wi-Fi for charging. It just magically works in the air. Jesse, obviously there's limitations on Wi-Fi for how far you can go in your home or in a public location. For the charging aspect, how much space? Because certain vehicles, you have an SUV, it's higher, or if you have a raised vehicle, and then you have a sedan, there's different heights. How much space is there?
Well, good question. In the most recently published SAE J2954, we have about, I'll speak inches and centimeters, we have about 10 inches air gap for the highest height. That's for utility vehicle. It's about 25 centimeters. And it allows for, it's really any light duty vehicle that goes on top of the pad will align and charge and have enough air gap for that.
How do you align it? Is there a camera underneath the vehicle? Is there a sensor where the driver knows how to drive over the pad? And what happens if the driver's silly and decides to put their wheel on top of the pad?
I'm going to answer initially, and then I'm going to hand it off to Kai, who spent a long time doing the alignment and the standards. But we've taken over the last decade to decide between testing and deliberation, and we really have decided upon a new methodology. It's called differential induction positioning system. And Kai Seeley, he led the sub team on that topic, so I'm going to let him talk about the more details.
Yeah, so within the alignment concept, it really is meant to be as simple as possible for the user. So the wireless power transfer aspect of it allows, as we discussed, for a little bit of movement back and forth and front to back. What the driver really needs to know is when they're parking their vehicle, when should they stop, ultimately. And so the way that the alignment is set up to work in the standard is there's a signal that's available to the vehicle. And as a driver, you just pull into the parking space as you would normally do so. That's how you select it. You don't have to do any sort of a pre-selection on a screen or anything like that. You simply drive in, it recognizes the vehicle approaching, and the vehicle will pop up a display and show the relative distance to the charging pad. And then at the appropriate time, you can put on the brake and park the car, and it will just start charging.
And the individual, the consumer, could just walk out. They don't have to do anything. They can go grocery shopping and come back, and the vehicle will have some sort of a charge, depending on the amount of charge.
Exactly. So in this case, you don't even have to think about refueling. It's a new sort of concept, kind of a power snack that gives you an infinite energy continuing over time, because all you're doing is what you normally do: park, charge, and it happens automatically.
When you go to a grocery store today, or if you go to a Home Depot or to a Lowe's or to any big box retailer, you have certain spots that says expecting mothers, there's handicap spots, and there's the delivery spots, the 15-minute. Do you see a point in the future where there's a dedicated global sign that means this is for wireless charging? Individuals know that these spots are reserved for them?
Absolutely. I think we're already starting to see spots for plug-in chargers. It would only make sense that there are spots for wireless chargers now, because they can be hidden, they can be under the asphalt. And now, again, you don't have to think about it. So those dedicated spots will become available to the vehicles that have wireless charging. And eventually that will become more ubiquitous, so that wherever you go, you're just parking and charging all the time, never worrying about where you're going to get your next amount of energy from to get to the store.
That builds the consumer trust. It also builds the adoption around electric vehicles. Jesse, from a speed perspective, you have an L1 charger, an L2 charger, and you have superchargers. The speeds are all over the map, and also depends on how many individuals are charging at that time. When wireless charging is commercialized, what charging speeds will be possible?
So we're starting off first replacing essentially level 2 at this point to 11 kilowatts, and it'll charge downwards compatible to about 3 kilowatts if you really want to overnight. And we published last year 2954-2, which is the heavy duty vehicle, which goes up to 500 kilowatts, and that's under development now, higher power wireless transfer. But the objective is, the grid's going to be the same. Whether you have DC charging or AC charging, it's the same. But, the concept is, we're replacing the plug, and we're replacing the concept of have to do anything physically beyond parking. But there's no issue with power sharing, I think you're implying. Yeah.
When J2954-2 comes out, is that focused on commercial vehicles, heavy duty vehicles, and how large will that all go all the way to a Class 8 truck, or where do you define the commercial vehicles in that?
That's exactly right. Currently, there's 2 use cases in that. In 2054, the guideline that's published, it's actually a bus and a Class 8 vehicle. So both of those vehicles are covered, and it's not just a document that's sitting on the shelf. There are real world applications now in California and Washington State, actually around the world, where there is bus fleets that are starting to do demonstrations in the order of 10 buses, and heavy duty vehicles, Port of LA, Port of Long Beach. There's a number of applications of heavy duty wireless power transfer at the port today. So it's happening. The big issue is right now we have a lot of competitors, and we're trying to get interoperability, and we're trying to think future. Same thing we did with the light duty standard. We'd like to have sort of every vehicle that pulls up to that application, to that use case, can charge. We're going to do that for heavy duty. It's just at the beginning stage.
In a nutshell, J2954 on the, let's call it a light duty vehicle, will enable the technology to scale. And with J2954-2, you're hoping to take the same thing to heavier duty commercial trucks as well?
That's exactly right. Yeah, we're planning to do that. And one cool thing I'd like to add on to what Kai was talking about regarding the alignment is that it's transparent to the customer, but also we're enabling something else. We're really helping the autonomous taxis charge themselves. Not just the manual charging and the automated parking and things like that. It really is opening the door to another phase of transportation, which is those taxis you see. I see them in Arizona and California where I live every day. And anyway, that's another feature that wireless charging can help. Is if you don't have a person there to charge, it actually can do it too.
Kai, from an alignment standpoint, you could program the robot to drive exactly over and stop where you want it to go. From a real world application, let's hypothetically say that there's wireless power transfer in a road, or roads plural. How does that work from an alignment standpoint? Does the driver have to drive in a certain way on that road, or is it designed to accommodate, okay, this individual might be an inch to the left, this individual might be an inch to the right? Is it designed to no matter where you are on that road to charge?
That's a good question. So what you're referring to, I think, is what we call dynamic charging, which is also a document that's in progress. And with dynamic charging in a roadway where you're charging while driving, the dynamics there are a little bit different because you are, exactly as you indicated, just trying to get the vehicle to nudge left to right a little bit. The technology for alignment that we've developed today and standardized is really for the static case where you're parking the vehicle, or as Jesse indicated, an automated parking consideration. But that doesn't prohibit it from being used in dynamic in the future. It's still under development.
From an industry standpoint, this is to both of you gentlemen, do you see demand from industry? If you look at a large public transit bus takes a lot of energy, and if they had in-road charge, they could hypothetically run longer, more efficient routes. Do you see demand from industry for the wireless power being built into roads?
J2954-3, which is a third document that we're just about to be, we're working on now. We're looking to publish it next year. That's the dedicated dynamic power transfer and wireless power transfer. And that is intended to support as it's bus routes and also truck routes, for instance, and inside the port, for instance, where they know the exact, it's going to be following a certain path. And there are demonstrations of that today already in Michigan. For instance, the state of Michigan has done something in terms of demonstration project and places around the world. And SAE 2054 is really looking to harmonize the coils and the alignment for the on-road dynamic charging. So without going into much more detail, it's definitely something that could reduce the battery size because you're constantly charging in that route. And we see that bus charging is a definite application where it's being used in demonstration phase today.
I would say, Kai, from a committee standpoint, you're taking this very broad, holistic approach to all the potential use cases. Is that how the committee initially started with this, or did that evolve from all the committee discussions as you started to build version 1, version 2, version 3? How did that all start to evolve?
Yeah, good question. So as we really started with the committee standards, we're always focused on what the industry wants next, right? What the OEMs want next, what the consumers want next. So I would say in the beginning, when we were starting with light duty vehicles, that was entirely the focus. All of these ideas, of course, were in all of our minds for potential in the future. And now that we've effectively standardized for light duty vehicles, and we can look a little bit further. So that's where the commercialization comes from the heavy duty trucks. That's where the opportunity comes for dynamic charging. But those are still in the works while we're refining and really getting people used to the nature of static charging, which is something that people will have to become comfortable with as well.
Do you view J2954 as a product? Ship version 1 of the product. Now we're gonna go back and build version 2 of the product and ship that. Is that a similar approach that you might be looking at that way?
You could look at it that way, except that what we're doing is adding capabilities rather than replacing the product. We're starting with a market segment, and then we're increasing the market segments to really become more ubiquitous and increase the opportunities for users and suppliers alike.
That's a really good segue. Jesse, from a technical perspective, how does wireless charging work? What has to be built to enable it? Because from a consumer perspective, say, this is great, but underneath there's a lot of stuff that has to go in to make this great.
I mean, just to boil it down, there are really, at least two different types, at least, that we'll talk about. The one that you referred to at the beginning with toothbrush and things like that, that's pure inductive. And what we're doing, and you need a contact with that very small air gap. But what we're doing is inductive resonance. Essentially, there is tuning in the circuit, usually with a capacitor, to a frequency. We tune it to a band. We call it the 85 kilohertz band, and it really enables us to have high efficiency. 93+% power transfer over an ear gap. We mentioned already this 10-inch, 25 centimeter ear gap. And, on the technical side, there are different types of coils and things like that, but we have actually found a way to have interoperability through a test stand and allow for, certainly right now we're starting with what's called the circular topology, but as we go towards more dynamic and more distances, as long as we have a reference test stand, we're able to do things in a performance way with high efficiency. And I know those who maybe not aware of conductor charging is actually not always above 90%. So we are actually pretty consistently in the 93% percentage. And what happens is the alignment just helps us get a little bit, a higher percentage in terms of high charge, but there's tolerance even if you're out of line as well.
How did you achieve that high percentage? Was it the way that the standard was developed that was enabling that to be achieved?
It was a process that, right now it's a lot faster because we understand it a lot better. But in the beginning, we started with simulation many years ago, and then we built up systems and tested them in laboratories. And then we get proposals from automakers, made proposals of coils, and we had competing coils as well. We had to, in a friendly way, duke it out and have, show them in a competitive way and put them inside of a laboratory. And, people think of standards of people looking in a room with white shirts and things like that. But we do, our group, every single standard is based on empirical data, which means that we've tested in the FDA laboratory with live pacemakers. We've tested not with people, with basically on a test stand. We've tested inside of Idaho National Laboratory, TDK Laboratory, and most recently on the test stand. On the test track at USU. So we're pretty active. To answer your question in a short way, we want to make sure that everything we put on paper is validated first, and it helps us with the process of deciding the standard. It has to meet that high expectations of 93%. So it wasn't by accident. It was by many years of working together towards. It's not about one supplier, but it is about making it possible for the entire automotive industry to make a selection of a coil and know that on the ground assembly side, it's going to work.
Kai, would the standard have been a reality if you didn't have access to the simulation tools that you have access to?
Yeah, the reality is today we're in a very heavily computing world, and simulations are very, very important. I think if it's not essential, it certainly is a shortcut to achieving that reality. Simulation, both in terms of magnetics, in terms of electrical interoperability, and even to the level of communications to make sure that everything works together. We would be years behind if we didn't have the level of computing capability and simulations that we have today.
Are the wireless charging pads, are they gathering data today, Kai? And if so, can you use that in future reversions of the standard where you're having actual real world data?
Yeah, so that's a good question with respect to data. And I think we should separate the types of data. From a privacy point of view, the systems don't collect anything personal about the drivers or anything like that. That would be a cause for concern generally. Rather, these systems collect data about themselves, about their operation, and making sure that they're operating correctly, right? And they communicate between the ground system, the infrastructure, and the vehicle in order to collaborate. And that's the extent of data and communication that occurs. Really, just to make sure the operation is as expected.
Is there any uptime data shared with the host so they know that the charging pad is working, so that we don't have the situation we have today with broken chargers that can be avoided? Is any type of that data being gathered and shared with the host?
Yes, that would be very important. And certainly we don't mandate that sort of thing in the standard, but from an operator and supplier point of view, it's an important piece of data that the host can be aware of. So most of the solutions that I'm aware of, including the one from WiTricity's, have a cloud-enabled application to really allow the host to ensure that it is operating correctly at all times.
Jesse, is the technology commercialized? Obviously, we're historically 7 to 8 year cycles on OEMs. That's just their historical data. So we'll just fast forward. We're 24. Let's just fast forward to 32, for example, that there's abundant OEMs have wireless charging. Do you see consumers putting wireless charging pads in their homes? Do you see this being used in public facilities at a Target or a Walmart? How do you see it being used initially?
Absolutely. So one of the reasons why it took us so long to get the first standard out is not just the testing and commonization, was that forwards compatibility, which is what you're asking. It's one of the reasons. So in the next few years, these are coming out, and we probably could list of all the suppliers. I'm going to name a few names. Certainly, WiTricity is doing this. Mahle and Siemens are working on it. I know Tesla's working on it. But the point is that the standard today, you can make a pad, put it in your garage, and then if you go through 3 generations of vehicles, that pad will still be should still be working. And in addition, that's the reason for the standard, so that we have a common understanding of what the vehicle will be charging to, common understanding what the coil would be. So with that said, and ironically, it's really one standard worldwide at this moment. So we've commonized with ISO and IEC, and in terms of the coil topology, which was really exciting. If from an automaker perspective, you can develop a vehicle, and a person who wants to buy something for his garage, he doesn't have to wait. If it's a U.S. vehicle, a European vehicle, an Asian vehicle, all of those will charge following the SAE standard.
This is really fascinating. And now you got the curiosity hat on. So you have one global standard. We had the J plug, or if you want to call it the CCS plug, and the NACS plug. I had a CCS vehicle, and now I have a NACS vehicle. And boy, oh boy, it's 2 different worlds, and it gets interesting, especially when you go on road trips. How did you get everybody to come to one global standard? Did you have to pull teeth? Well, what did you do to achieve that?
I will tell you, it was a conscious effort. So when we started this effort, there was a Chathamel plug, now which is on the way of the wayside. There's a Tesla plug. There's a CCS plug, which are still looks like they're converging. And we really thought we need to get one coupling, because you don't want to have to drive out of your space and drive to another space. You have to find compatibility. So we sat together. We actually have regular meetings with the Chinese GB. We meet up with ISO. We meet up as a German group that coordinates things as well. We have representation. Kai's a great representative also in some of the international forums for frequencies. So we don't only get involved in standards, we get involved in regulations of frequencies. So it is a conscious effort. It's a team effort. It does take some doing, and we've actually had one meeting where all the standards group met together before we published the first standard, and made sure that we had alignment in the fact that there wasn't resistance, and we plan to in the future to work together closely with ISO, and maybe sharing some of our document to make sure that there aren't clashes with automakers and stuff like that. So it's a conscious effort, and we were lucky to have the industry and also the standards groups open to that.
I can imagine the regulatory between the EU, China, and the US of getting everybody to agree on frequencies, and how you did that, I don't know, but I'll say extremely well done there. There are going to be a lot of individuals, and I got involved in an X chain about retrofitting vehicles, and I said, okay, so I linked to the standard, and a gentleman came back and asked more questions. I was impressed that he bought it and read it. Will there be limitations to the type of vehicles that will be able to be retrofitted in the future? I asked because, I don't know, let's go back 6, 8, maybe 10 years when you used to be able to go to AutoZone and get a backup camera. Oh, you can put on the license plate and that was relatively easy. There's not power, just a wire essentially. Will there be limitations to the types of vehicles that will be able to be retrofitted for wireless charging? And on the backside of that, do they have to have a certain software that would do it inside the vehicle already?
Sure. So I think there are two parts to that particular question. Number one, on the standard size, of course, any vehicle can be retrofitted and maintain interoperability. But then there's the vehicle side. As many standards as there are in any one vehicle, vehicles still have some proprietary aspects. And it is important not only that the wireless charger work amongst themselves, but also with the vehicle. And what that means is that oftentimes there will be custom firmware that has and adapters that have to be made for a given vehicle. So for an aftermarket solution, those do have to be considered one at a time in order to account for those specifics that are on each vehicle.
Will there have to be a sort of a testing that it will have to go through? Will have to meet some sort of certification to go on the vehicle, a stamp of approval? Will that have to occur?
So there's two parts to that question too. So on the side of standards and interoperability, making sure that the vehicle receiver and when it's mounted on the vehicle is interoperable with the infrastructure is certainly something that is covered within SAE J2954, and laboratories would test to that to make sure that that interoperability exists. Additionally, there's a safety aspect to that on the ground infrastructure where you have standards like UL 2750. The SAE J2954, that committee, we cooperated again with discussions to really make sure that that was created correctly also. And then you have the side of regulatory on the vehicles. And I would say the OEMs, vehicle manufacturers, are very picky about what goes on their vehicle. So it does take a lot of effort to test with the vehicle and ensure that everything's safe, interoperable, and meets the expectations of the OEM and the users of those vehicles.
Jesse, when developing a standard, there seems to be a common trend here, collaboration. How much collaboration truly goes into developing a standard? And I'll put my product hat on and shipping the standard, which is the product essentially.
A lot. No, we generally have had face-to-face meetings. It used to be about once a year because we would meet on a monthly basis, and we would meet around the world. So we've met in New Zealand, we've met in Europe, we've met in Asia, and we've met in the U.S. and many places as well. And that's just not because we love to travel, but it's because it's not just collaboration between automakers. There's at least 8 automakers around the team. There's at least 5 charging suppliers. There's every government agency has been involved and things like that. But without losing the topic, there's a lot of collaboration where we have to create proposals, review the proposals, and vet them. Sometimes it involves voting, and sometimes involves making a choice. We've actually had to make choices where we've had to pick coils where it was a consensus and not everyone won. But at the end, we do everything the SAE way, which is, the majority rules. Usually it's a significant majority. And it does take, but we have to convince ourselves that it works for the industry. And that's why we are an industry team, but we would like to make this a commercial product at the end so that anyone can make it and anyone can buy it. So yeah, there's a lot of collaboration involved.
Just with the goal of becoming a commercial product, it raises the trends in technology. They're both evolving rapidly. How is the committee constantly staying on top of new technologies and trends that perhaps the OEMs will look to implement in future reversions of their vehicles?
So I can say that, just for instance, light duty is solidified at least to the point because we're kicking off production. We are always keep the door open for innovation in that we have a performance-based standard, which means that if you come up with a new development, it's not prescriptive. It means that you have to prove that you're safe, and you have to prove that you can do it highly efficient, and you have to prove you're within the EMCMF limits, which we haven't talked about much. But And all those things together, you have to prove it on a test stand. And what Kai was referring to before is we have an MOU with UL, very much like UL tests things. Well, you can test your document, you can test your coils to 2954, and it gives you guidance of what are the, what you shall on the safety side comply to. But that leaves the door open for innovation, because you can have different designs in the future as long as you're compatible. It's forwards compatible in that way. We can test out new designs. I can tell you that one more answer to the question on the heavy duty side is that we're in the finding process of what the coils or the standard test stands will be. And that requires us to survey the industry about the latest technologies they're putting out today. But even when we solidify things in a test stand, it doesn't mean that innovation is done. It just means that we have a line in the sand with regards to what will be the reference test stand.
Kai, the committee, as Jesse elegantly said, is leaving the door open to innovation. With that door open to innovation, how do you see the technology that powers wireless charging evolving as OEMs begin to integrate it, begin to ship it, get customer feedback? How do you see that potentially changing?
Yeah, so as we move forward with technology, there's always a desire to make it cheaper and better at the same time. And that will continually drive innovation to a level that's acceptable to consumers, because ultimately we want to see wide adoption and ubiquitous adoption. That technology evolvement will continue based on feedback from users. It will continue based on the intent of future standards. So thinking about the dynamic charging, thinking about heavy duty charging, and how we interoperate as an ecosystem, not just between the vehicle and one piece of infrastructure.
Kai, fall's coming. Leaves are going to start falling off the trees. And after that, the white stuff known as snow is going to show up. What impact, if any, will the various different weather elements have on the wireless charging?
This is the great thing about wireless charging, because it really highlights its benefits. In essence, when you have snow, leaves, rocks, dirt, cement, any of that over the wireless charging pad, it will not affect the wireless charging. It can be entirely hidden from view, and still all you have to do is pull into the parking space, park, and it will charge, even though the ice and snow remains on the wireless charger. You can't say that so much about plug-in charging. I know a lot of people are skittish about, pulling or plugging in those same conditions.
Then, after we go through the cold months, we come to the warm and eventually the hot months. This is a personal story. I was on a plane and we couldn't land at the Phoenix Sky Harbor Airport because they said the ground was too hot. I was like, oh, this is a first. I've mechanical delay, insert every excuse under the sun that you can have. How about heat? Because there's certain parts of the United States of the world, it gets very, very hot in certain months. Are there any issues with heat and with the ground being so hot?
Yeah, so of course, from an electronics point of view, we like it to be the perfect temperature, but the reality is we're used to extreme temperatures in automotive environments. Vehicles see extreme temperatures on the high side and on the low side. And this equipment really has to meet those same automotive temperature standards in order to be deployed. So that is a given expectation.
But a given expectation, then you got a happy customer at the end of the day. They're not going to have to worry or finagle or get stressed out. Jesse, what is the future of wireless charging? Because the way that yourself and Kai presented this, it's very bright. But in your opinion, what is the future of wireless charging?
The future really is, it also has the potential to help people that are apprehensive of buying electric vehicles because they have to plug in every day. But the future of wireless charging, we really think is going to start in replacing or supplementing level 2. So we think that overnight charging with some premium vehicles, you've heard the Tesla Cybertruck, we mentioned it, also Stellantis as well, that they're putting into their vehicles. But the future, we really believe, is going to be very important, especially with, we've talked about light-duty vehicles, but also with heavy-duty vehicles, with buses, electric buses, to reduce fleet costs and reduce reliance on, higher power energy. It's possible to put charging along the bus routes while you're stopping. You can kind of increase your range, and then overnight you have less of a charge. And we really believe that near-term future, once people have a chance to try it out, I really think it's going to be hard to go back to the plug. Because once the customer has this transparent, act of just parking and seeing the green light, you don't have to think about plugging it in. I will say there's something else in the future. I do want to mention some of the innovations we're working on are bidirectional charging, which is actually coming at the end of next year, we're planning, which is vehicle to grid, which we think will increase the opportunity for grids to use electric power from vehicles, because you can't always guarantee someone's going to plug their vehicle in overnight, especially if it's charged and they don't want to, once a week or whatever. But if you constantly have this place where it's always connected, it increases that opportunity. We're also planning on moving. Right now we're above ground with light duty. We think it's going to be able to be flush to the ground. And also we're looking at higher power with light duty as well as high power with heavy duty. So we're working on a lot. So come back in a year and you'll see, working on three standards, at least one or two of them, we should have some results.
I'll summarize this way. The standards that you gentlemen in the committee are developing are going to enable wireless. The standards that you the standards that you gentlemen in the committees are developing are going to help electric vehicles scale, because you're eliminating the friction point. Now in my new car, I don't even have a key. Get in the car and just go. I can't go back to any other car because you become used to it. I pull up to my house, the garage opens. This is great. Well, next thing you know, I pull up to my house and it charges. Great. I'm not going back. You've got a customer for life, and you start multiplying that across millions of individuals. You have a lot of happy OEMs and a lot of happy consumers. Then when we have autonomy, you have happy fleet operators. So let's call it, I'm going to call it the standard happy. There you go. The happy standard. Gentlemen, this has been a really insightful conversation. I can't wait to have you back on again as you release the commercial vehicle standard, release the bidirectional standard, because this technology is truly going to change the future of electric vehicles, commercial vehicles, and who knows what else you gentlemen are going to standardize next. As we look to wrap up this insightful conversation, what would you like our listeners to take away with them? Jesse, we'll start with you, please.
Yeah, and I'll say what I said in the beginning. We're at the starting gate for commercialization of wireless power transfer with our first, really complete standard. And we really think that we're trying to help the path of reducing petroleum by getting electric vehicles more accepted. Really happy to have this standard out. And thank you for the invite to be here.
You're very welcome. Kai, what would you like our listeners to take away with them today?
So the future is bright. The opportunities are amazing with the technologies that are coming online. Standardization is an important part of that. And as we move forward with wireless charging for electric vehicles and consumers have the opportunity to experience it, additional features will come, like we already talked about with bidirectional charging, allowing us to help balance the grid, which will become very important from an electrification point of view as more and more electric vehicles come online and the level of power increases throughout the world that's required. But it comes with great benefits to the economy, to the ecosystem, and I really look forward seeing what these standards and this technology will really bring to the next generation.
Standards make the world go round. Standards make vehicles charge. And soon, standards will make vehicles charge wirelessly. Today is tomorrow. Tomorrow is today. The future is wireless charging. Jesse, Kai, thank you so much for coming on SAE Tomorrow Today.
Thank you very much.
Thank you.
Thank you for listening to SAE Tomorrow Today. If you've enjoyed this episode, please kindly rate and review on your favorite podcast platform. Your feedback is invaluable to us as we work to produce world-class content. Be sure to join us next week where I'll share my insights and opinion on another episode of SAE Tomorrow Today Unplugged, where I'm going to break down Tesla's robotaxi announcement, what the impact's going to be on the industry, and the big question that you're probably wondering, when and if does Elon deliver the robotaxi? Tune in to find out.
SAE International makes no representations as to the accuracy of the information presented in this podcast. The information and opinions are for general information only. SAE International does not endorse, approve, recommend, or certify any information, product, process, service, or organization presented or mentioned in this podcast.